Hello, this is Sebastian Lerich from the CloudScale-Project. Welcome back to our new series on ScaleDL, our language for modeling and for analyzing cloud computing systems. In the previous screencast, we have seen how we can model dynamic workloads using the Decay load intensity model and linking it to our already created extended PCM instances using our ScaleDL usage evolution model. In this screencast, I want to introduce you to some other extensions we made to the PCM, so that also now comes as a part of the extended PCM. In particular, we enabled the specification of service-level objectives, which becomes pretty handy when you want to specify cloud computing systems, since they typically specify some promises. So cloud providers specify promises in terms of service level objectives. Our new model essentially resembles that, and you can specify something like, okay, I want to have a service level objective that states I always have a response time below 3 seconds at my cloud bookshop, for instance. So to specify that, we go to our CloudScale environment, of course. I again have my workspace prepared with the Cloud Store model you also find in our Git repository. Within the usage scenarios folder, you in particular find an SLO I already specified before the screencast. So you can have a look at this example, or you create a new service level objective. I show you now how to create a new one. So first of all, you can maybe you just put it in this folder as well. So we can click on right click on usage scenarios, choose new and other. We want to specify a service level objective, so let's enter service level here, and we are provided with service level objective model. Here we choose next. We have to specify file name. Let's say 3 seconds response time is the SLO we want to specify. We go with next. We have to choose a root model object. For our model, we choose service level objective repository here. So that's a repository, a catalog of different service level objectives. This allows later on to add more if you want to have more. So choosing this as a root object, we can now press finish. And the generated tree editor opens. We can have a look at the contents of the file. The service level objective repository is in the root as specified. It doesn't come with any properties, so we can just right click here, choose new child, and add the first service level objective here. So now we have one service level objective. We have to enter a description for that. We can, for instance, enter that we models that we want to model a 3 seconds response time SLO as an upper limit for consumers. Okay. We have to specify a measuring point and a metric description. I come next to that. First, I enter a nice name here. So I name it like the file name. It's a 3 seconds response time SLO. Okay. So next we have to specify a measuring point and a metric description, which actually characterizes what we want to measure and where. So the where part is a measuring point. So we want to measure response time at some place of our system. And we have to decide for the place where we want to measure it. So we can, for instance, choose a usage scenario as a place where we want to measure. So I prepared a PCM measuring point already for the browsing mix, But for the ordering mix, for instance, I did not provide yet a measuring point. So in this usage scenario for the ordering mix, we may want to measure the response time as received by cloud consumers of this scenario. So to do so, we can just right-click here, again on the folder, choose New and Other. Now we choose so-called PCM measuring point. There's also a model for generic measuring points, for models other than the PCM, but in our case, the PCM measuring points fits quite well since we want to add measuring points to our architectural models. So in choosing PCM measuring model, we can now again choose a file name. So as I said, we want to have a measuring point for the ordering mix. Ordering. Oh, there's already a measuring point. Did not see that. Okay, then just name it another ordering mix measuring point. I choose next. I have to select a root object again. Here I now select type of measuring point I want to model. In our case, it's a usage scenario measuring point. You see here you have several different options for other measuring points. For instance, you can add one to active resources such as CPU and hard disks. You can add them to assembly operations, to passive resources, entry-level system calls, external calls within service effect specification, linking resources within resource environments, subsystems and systems within Palladio systems. So that are the places where you can essentially attach a probe where you want to measure or audit service level objectives. So in our case, that's a usage scenario we are interested in, and we can just press finish here. And in the new tree editor, the only thing we actually have to choose for this root element, usage in our measure point, is a concrete usage scenario that is linked by this measuring point. So as we wanted to use the ordering mix usage scenario, we just drag and drop the usage model into the editor, which then gives us the option to just choose the usage scenario ordering mix out of the properties view. Okay, so we now specified a measuring point for the ordering mix usage scenario. We save that model, of course. And we can then go back to our SLO model. So we now need to link this measuring point we just created inside the properties view. For that, we can just drag and drop again the just created measuring point. So here we see another ordering mix measuring point. We drag and drop that into the tree editor view. We can then simply select the measuring point from the property sheet here and are quite okay now. So next we need a metric description stating where or what we want to measure. So in our case, that is simply response times. So as we did not load yet some metric descriptions, we have to do that. Luckily, we prepared for the PCM a set of metric descriptions that allow you, for instance, to choose from response times or throughput, utilization, or a set of different metrics. So the easiest way to find it is, I guess, to copy it from another model. So let's have a look at the browsing mix SLO to find an example. So here you already see that we specified a numerical base metric description for response times. And we got that from this metrics model, which is linked in a path map here. Okay, so I will just copy that path map. I think that's easiest with the text editor of that model. So I can just go to the text editor here and copy that path map to our previously specified metrics. So I copy that string. Alternatively, you can also just copy it from here, so that never changes, it's always the same. And we can go back to our SLO model here. Now we load these metric descriptions into our model. So we just right-click in the tree editor, say load resource, and here we can just enter the string, the path map we specified for you, to our repository of COM metrics. And now they are known to our SLO model editor, which has a consequence that we can now select between the metrics that are available here. So here is the set of pre-specified metrics we can choose from. Note that there are also the new CloudScale metrics included. So what you see here is you have some base metrics, and one of these base metrics should be response time. It's here. We go with response time since we are interested in response times. So we now specified a service level objective stating we are interested in the response times at the usage scenario of the ordering mix usage model. What is still missing is the threshold our SLO should relate to. So we say it's a 3 seconds response time SLO. We somehow have to specify these 3 seconds. For that we have to right-click on our SLO model element and choose New Child. And here we can now specify different types of thresholds. So we have 2 types of thresholds, hard and fuzzy thresholds. Hard thresholds are like really fixed. Fuzzy thresholds can be exceeded with certain probability, and it's not too bad. Say it like this. We also distinguish between upper and lower thresholds. So we now talk about an upper threshold, since the upper limit in terms of response times for us is 3 seconds. Could also specify a lower limit in case we want, for instance, to have, if you relate to other metrics where which negatively correlate with high values, we would use lower thresholds, or if we could, for instance, also add lower thresholds for scaling down rules in self-adaptations. But for this first simple SLO, we just specify an upper threshold, hard threshold here. So we choose that. And here we can then enter a threshold limit. We attached a nice serialization to that, such that you can specify here something like 3 seconds. It's really in the unit. So as is known to our serializer, it's recognized as seconds, and it's type safe, so to say. So that's not just a simple string, but it's checked against known units and measures. So that's essentially it. We specified a 3 seconds response time SLO. Later on we can make use of such a service level objective in analysis. For instance, if you want to determine the system capacity, capacity is compared against such SLOs. And system just satisfies its capacity if all SLOs are met. So we can run these kind of analyses. After analysis, we can also check how many SLOs were met, how many were violated. We can highlight that in diagrams, and so on and so on. You will see that in a separate screencast. That's it for the time being. So in the next screencast, you will actually see then something more about ScaleDL. We will move down to this model for architectural templates, which allow you to model high-level architectures and architectural elements in a reusable manner. So it becomes quite easy using architectural templates to model something like, I want to have scaling out inside my system. I may want to vertically scale, I need a load balancer, so stuff like that is quite easy there. And it comes with a special an analysis run that allows you to measure metrics like capacity, scalability metrics, efficiency metrics, and elasticity metrics. So that comes all with these architectural templates, which you will see in the next screencast. And once we have our architectural templates in place, we will then show you also to how we can run then analysis based on these specified models. Okay, so stay tuned for the next screencast. Thanks for watching.